and I would like to welcome James Goff, who will be a presenter today. James?
Good afternoon. My name is Jim Goff, and I'm an instructor with the Educational Services team here in Redlands, California. Joining me today is Kasha, who is also an instructor here in Redlands. I want to welcome you to today's live training seminar. Today's presentation will be Introduction to ArcSDE. Today's seminar will be broken into 3 parts. To start, we'll talk about what ArcSDE is and the architecture behind the product. Then we'll talk about ArcSDE and the benefits ArcSDE can provide. Finally, we'll talk about best practices and performance considerations when setting up ArcSDE. Throughout the presentations, we'll show examples and provide software demonstrations. We also have the opportunity for question and answer sessions at regular intervals. So let's get started and talk about the basics of ArcSDE and the architecture behind it. So the GIS data in the organization is usually a process that kind of evolves. So it starts off with maybe a couple people working as the GIS department with a couple of GIS files on their local machines, and they pass the files back and forth. But as the GIS department grows, we get a few more people, it starts to make more sense to maybe move the information to a file server. So now I can share the information back and forth across the network easily. I don't have to worry about if somebody's out that day or is on vacation, something like that. And it also gives me the opportunity to back up the files, so I can set up a regular scheduled backup to happen nightly for all the files because the data becomes very important. But as the GIS projects grow in size and in number, you run into performance problems with the file server, maybe file locking problems between a couple people trying to work on the same files at the same time. This is where ArcSDE, the spatial data engine, will allow you to leverage your database to store GIS information. So ArcSDE will provide performance and organizational benefits for sharing your data across the local network. And if you're using ArcIMS, the Internet Map Server, to serve out information to other people or organizations, ArcSDE can provide performance benefits as well. So with ArcSDE, you can have all of your data in a centralized spatial database. So rather than have the information maybe broke up into certain sections of the city, and I have some people working on editing one part of the city and another person working on another part of the city, I can have all of the information as one big set of streets, parcels for the entire city or for the entire county. So people can work on it together, it works a lot faster, and when I zoom into specific areas of the map, ArcSDE can use indexes to pull that information back very quickly. So you can easily combine the GIS data in ArcSDE with other applications. So maybe you have your accounting data in the database as well, and you want to join the information together with your GIS data so that when somebody clicks on maybe a store, I can show the sales data for that store. And with ArcSDE, it's easy to combine information like that. So another benefit for ArcSDE is concurrent access. So I can, instead of having the files locking problems or having to break up my data into multiple parts so that different people can work on it at the same time, ArcSDE will allow multiple people to work on the same data at the same time without duplicating the data. So what it's doing is keeping track of the changes as people are making their changes, and it allows me to save my changes maybe at a later point in time. So if I've got a project that maybe lasts for a week or so, I can work on my changes, don't let anyone see them until I get them okayed, until they're final, and then send them up so that everyone can see the information. And with ArcSDE, you'll be saving your information into a database. The database will allow me to set up security, so I could set up roles for specific users based on their function or department that they're in. So I could say, oh, some people should have access to certain feature classes or certain data, and some people can look at it, some people might be able to update it, and I can set permissions and take away permissions from the role, and then everybody who has that role assigned to them will automatically be affected. So the backup and recovery, all databases should have administrators to do backup and recovery, but the advantage to a database is if it goes down, let's say at 4 o'clock in the afternoon, rather than have to restore the database to yesterday's backup, what I can do is restore it to a point in time just before the failure occurred. So I don't have to go to everyone and say, hey, we've lost a whole day's worth of work. For scalability, the database is going to work and use memory caches and disk efficiently to serve more people, so more people will be able to simultaneously use the data without feeling performance hits for them. So another advantage to ArcSDE is it's going to be fully integrated with all of the other products like ArcMap, ArcCatalog, and ArcIMS. With ArcSDE, we're not actually storing any information in ArcSDE. All the information is going to be stored in your database. So we currently support, you're going to need a database. We currently support IBM DB2, Informix, Oracle, and SQL Server. So one of the performance gains that you get from ArcSDE is when clients send requests, ArcSDE is going to take the request, change it into SQL statements, elaborate SQL statements to pull data from the database. As the information comes back from the database, ArcSDE is going to pull the information in small buffers. The small buffers then get sent back to the client. The client can render the individual small buffer while ArcSDE is pulling the next buffer of information from the database. So we get both machines working together simultaneously to reduce the response time for the requests. So ArcSDE has the ability to read and write spatial data to the database. It's going to act as the translator like we talked about. The client sends requests into ArcSDE. ArcSDE translates them into SQL statements. The SQL statements go into the database. We pull the specific information that we need. ArcSDE then filters and passes the information back to the client. All of this is happening through a dedicated TCP/IP port, so that will save the network administrator some time, so I only have to open up one dedicated port. So let's start with a software demonstration by connecting and getting some information from ArcSDE. So I've got a map, and let's say I want to go after and pull some information from ArcSDE. What I can do is just to go to File, Add Data, and I've got a list under database connections of current connections that I've already set up. So I've got connection information, names that I've made up. I could change the names of the connections if I wanted to, so I could do a slow double click and change the name of one of them to something like that. Or if I want to get the information, notice that a lot of the connections have a red X next to them. That means they're currently not active, they're currently not connected. If they don't have a red X next to them, that means they're already connected. If I want to connect one, I just double click into it, or I can double click into a connected one and pull back the information that's available to me in that database. So one of the big advantages for ArcSDE is it's not so much different than pulling information off the file system. So when I pulled the information off the file system, basically I'd go through a list of folders, look for specific information, and then it would be represented very similarly if it was a shapefile or if it was a coverage, and I could pull that information into my map. So ArcSDE doesn't require a lot of extra training, a lot of extra work. I can just go pick out a specific information I want added to my map, add it in, and it will quickly render the information in my map. Once the information's there, I can identify some information, pull back some attributes about it, maybe the name, maybe the road ID, some information like that. And I've got the ability where I can zoom in very quickly to a specific area. So it works out pretty nice. So let's go take a look at a map that I've already created. So in this map, we've got the roads that we were looking at before. This time I also added the Wilson County raster. And what that contains is about 3 gigabytes of information behind the raster. So it draws very quickly initially, and then as I zoom into a specific area, it pulls back more information with the roads and the raster as well, until I get down to a point where I can see individual structures and maybe some cars, trees, things like that. So you can see in ArcSDE, it's going to work very fast. The machine that I was pulling this from is just like a small laptop with 1 CPU and like a gig of memory, and yet it still can pull tons of information back very fast. One thing I wanted to show you is, so far we've looked at using existing connections and looking at an existing map. Let's say that we wanted to create a brand new connection to ArcSDE. So we've got our information here, and let's say I want to create a brand new connection. I can go to File, Add Data, and when I do that, it brings me back to the connection I was in before, where I was looking at my information. I can go up and see all my connections that are available to me, and if I want to add a brand new connection, I can double-click the Add Spatial Database Connection, which is going to bring up a dialog for me to fill in. So with the dialog, I get to put in additional information, so I can start maybe by putting the machine name or the IP address of the server that's actually running ArcSDE. So that'll put me in touch with the specific server. Then I need to enter the service name or port number. So the service name or port number is going to put me in touch with a specific program, in this case ArcSDE. It kind of works like if you wanted to get in touch with me at ESRI. So you would dial ESRI's main number, and then you'd put in my extension, and then you would get in touch with me. The port number or service name works kind of like an extension. Then I've got information here about username and password. And if this was set up for me in the database previously, and as long as I type it correctly, I'll test the connection and it would come back grayed out. If I typed in something incorrectly, it would come back with a dialog saying an error message and what the error was. I also have the option to save the password, the name and password, in an encrypted file on the client, so I don't have to keep retyping it. I can have that connection stay around and double click into it anytime I want to. So I'll go ahead and test my connection. It grayed out, it came back okay. Now that I saved my information, so I can use that slow double click to actually change the name of the connection, and let's change this to Jim's Connect. And then that becomes a new connection that I could use later on. So one of the other components of ArcSDE that we were talking about in the presentation was the ability to tie together information, my GIS information, with other data that may come from other departments or other organizations. So I've got another demo here with some shops. So some coffee shops. I can, if I wanted, identify one of those, and it pulls back some general information like the name of it, being around the world. It's got the shape information, which is its location, information like that. But let's say that I really wanted to tie in my sales data. So what I did in this case is I created a view of the information tied together with this other table that contained the sales data. So now when I identify, it actually pulls the name, being around the world, along with some sales data. Yeah, some not very original sales data, some I just created, but it tied those two tables together and was able to pull that information pretty quickly. So one other concept that we talked about in the presentation was the ability to create roles and for people to see, to allow other people to see information that you're working on. So let's connect into Fred's connection. And then when I do that, his list will come up with kind of a short list of what he's able to see currently. So I've got some information. I can see a couple of the feature classes, maybe a table. But let's say I wanted to give access, Wilson wanted to give access to Fred. We could actually go into Wilson's connection, and I can pick something new that he doesn't currently have access to. Maybe it's this export output. So what I can do is I could right-click on that, go to Privileges, and I just need to either grant the access directly to Fred, or I can grant the access to a role that Fred currently has. And Fred currently has a role called Fred's Group. So what I can do is grant select access, apply. Oh, I currently have that open. Let me find one that I don't have open. Here we go. Privileges. And let's do Fred's Group. Grant him select access and hit apply. So when I do that, and then I click back into, let's go back to Fred. If I disconnect and then reconnect as Fred, I'll see that now I should have access to this new shops. So it works out pretty good. Another thing you could do as Wilson is I could grant other privileges more than just select. So let's say that I had a project called Wilson, and I had people in the project that were viewers. So I could grant those individuals select access, and then I could go in and change that for my editors. And when I pick one of these, they all come alive, and I'd give them full access. So they have the ability to do not only select the information, but to do updates as well. So that works out pretty nice. One other thing that we talked about a little bit was versioning, which is basically editing inside of ArcSDE. So I've got my coffee shops, and if we click on the Source tab, we can actually see that coffee shops is part of the default, which is something that everyone can see. So everyone could see this work. Let's say that I want to do some edits to the coffee shops, but I'm not ready for everyone to see it yet. I want to just kind of do it for myself, maybe run it by my boss, make sure he's okay with it. So what I can do is right-click, change my version to my own version, and then I see a different look of the coffee shops the way they are at this point in time. So what I could do is maybe go through, start editing, and then maybe select a specific coffee shop. Maybe I want to edit something about the coffee shop, and I'll just change the name to 123. In my map, I can refresh the map and it shows 123. I can do edit, save my edits, stop editing, and I've completed my changes. But if I go back to where everyone's looking at the information, and I go change my version back to what the default is, nobody sees the changes I've made, or even the coffee shop that I was working on. So maybe that's not coming around for another month or so, and I just don't want to show everybody yet. Great. So in review, ArcSDE, the spatial data engine, is an ESRI product which will allow you to leverage your database to store GIS information. The benefits of ArcSDE is the client and server machine work together to reduce processing time for requests. It's a centralized database, so I can have all my information in there. I don't have to worry about where the file is, trying to track it down. I can give privileges to that specific data to a specific group or a specific person. And it's fully integrated with the ArcGIS tools, so it'll work with ArcMap, ArcCatalog, and ArcIMS. So now let me turn it over to Kasia for some questions.
I've got a question here from Anne from Reading, and Anne is asking what benefits or features of SDE are not available by using personal geodatabases. The primary difference between a personal geodatabase and a SDE geodatabase is that SDE allows you to do versioning, so multi-user editing. The feature that Jim just described a couple minutes ago. So it is the ability for multiple people to be editing the same piece of data at the same time, and each of their changes will be preserved in a version. So each of them are accessible, as opposed to a personal geodatabase where as soon as one person starts an edit session against that personal geodatabase, a database lock is issued and no one else can go in there and start editing. Let's see, let's take another question. This question is from Amy from Houston, and Amy's asking, can I create two different SDE services against one single database instance? And absolutely. What you can do is you can have multiple SDE services running against the same spatial database. You can do that, or you can have multiple services running in different databases. So that is absolutely necessary, possible. Sorry. Jim, would you like to take a question?
Sure. Thanks, Kasha. Jim from Winnipeg had a question. To estimate disk space consumption, if I have a gigabyte of data, does that translate into a gigabyte in SQL Server disk storage? Well, the database is going to add a little bit of overhead because of all these extra indexes that we're talking about, and it's going to create some additional tables as well, so there is going to be some overhead to that. It kind of depends on the type of data you have and how much data, but what I would probably do is load a small sample set of data in, test that, and see how much space that takes, and see what the relationship is there, and then extrapolate out.
Let me take one more. This is from Shri Krishna, who is asking, what are the performance issues if the database and the ArcSDE are installed in different machines? We usually recommend that for best performance that SDE and the RDBMS were to locate it on the same box, because they actually talk to each other a lot. There's a lot of that goes back and forth. You certainly have the option of loading SDE on a remote machine. You'll be just using a little bit more of your network, because if they're loaded on the same machine, they're actually using shared memory. So it's just a little bit faster.
Great. Thank you, Kasha. So let's continue on with storing your data in ArcSDE. So let's talk about storing your data in ArcSDE and the benefits that that ArcSDE can provide. So ArcSDE will allow you to store vector and raster data. Both types are going to have a spatial reference, which is going to define its location on the Earth. From the user standpoint, the data is going to behave in ArcSDE as it did before in the other formats. So like if you had a file format like a shapefile, it's going to work very similarly in ArcSDE, which is really a benefit because I don't have to retrain people or do a lot of work that way. The performance is going to be a lot better. It's going to actually take the data from the file formats, though, and translate it into the database. So it's going to take that information and take the vertices, the x, y coordinates, maybe z for elevation, and pull the information into ArcSDE, reformat it, change it into a table format, put indexes around it. The raster data, the same thing. It's going to pull the TIFFs or bill files from the file system and actually take the information, the pixel information, and load that into the database. So storing vector data in ArcSDE, many formats can be loaded, like shapefiles or coverages. Once they're in the database, though, they're all going to be feature classes. They're going to work similarly like they did in the file system, but they're going to be actually of the same type. They're going to work together. If I wanted to later, I could export them back out into file formats. ArcSDE stores the geometry, points, lines, polygons separately, but then I can bring them into a map and layer them over each other. So like I've got a feature class here, let's say of these lines which are really streets, and I've got Tora Bora Street. Logically, to the end user, that's going to look as just one row in the database. And then every different feature is going to be another row in the database. So reducing work with indexes, ArcSDE uses indexes extensively. And indexes have an advantage to the database. It's kind of like if you're reading a book and you wanted to find information in the book. You could read the entire book in case the information is in a few different places, or you could look in the back of the book for the specific pages where that information could be found. So databases use indexes to reduce the amount of work they have to do, which increases performance, and ArcSDE uses a lot of indexes to track the information it needs to get quickly and bring that back to the clients. Besides regular database indexes, ArcSDE implements a spatial index component. So when I'm looking for information, let's say if I wanted to find an amusement park in a map, I could search the entire map, which might take me a while, or I could look in the index of the map and find out, hey, the amusement park I'm looking for is maybe in section A4. So I could go up to A and over to 4, and I can search just that area of the map and not the entire map. So it'll save me some work. ArcSDE implements a very similar structure so that when I'm zoomed into a specific area, or if I'm trying to find something in a specific area, it can quickly bring that information back to me. So storing your raster data in ArcSDE, the smallest unit of raster data is going to be a pixel. So we're pulling the pixel information. Pixels don't really have any relationship to each other except that they're next to each other. So a pixel doesn't know if it's part of a house or part of a road or part of a tree. It's just a number in a specific location. So it wouldn't make a lot of sense for ArcSDE to store each individual pixel as a different row in the database. So what ArcSDE does is it tiles the information up into sets of pixels. And then it stores those sets of pixels and it calls those tiles. It keeps row and column number of the tiles and indexes those row and column numbers so that it can quickly pull out specific tiles. So this works out really well if I'm zoomed into an area that maybe could be represented by 4 tiles. I can just go in through indexes, quickly pull those 4 rows out of Oracle and send those back to the client so that they can render that information. So pyramids is a reduced resolution copy of the data. So let's say if I wanted to initially pull up a map, and that map was of my entire county, and it was of a half-foot resolution. So a lot of data, you've got to pull all this information across. What ArcSDE could do is it could go into the database, pull gigabytes of information out of the database, send it over the network. The client would get all this information and say, oh, this is much too much information for me to represent. It could resample it and draw you kind of a poorer looking picture. And that could take hours, maybe days, to get all that data to you. But what ArcSDE does instead is it creates these reduced resolution views of the data and then stores that information in the database. So that when I come into the full map and I want to see the full map of the county, it quickly pulls that up and shows me that map. It's a reduced resolution view, but way from the full extent of the county, I wouldn't be able to really identify a specific tree or a specific road anyway. So let's take a look at that first demo or one of the first demos that we looked at, where we were looking at the roads with the rasters behind it. So when we take a look all the way zoomed out, we notice that we were talking that it was 3 gigabytes of information, but it came up very, very fast because it's really, now we know from behind the scenes that it's really showing us the pyramid, the highest resolution. So it's showing me a reduced resolution view of the information. I can't really see the roads anyway, so it wouldn't make much difference. And then as I zoom in and start pulling in more and more information, it starts showing me more and more detail. So now I can see maybe some cars, maybe some buildings, and then as I zoom in even farther, I can start seeing the individual trees, houses, and cars. Let's go in and take a look at the information that we were just looking at. So the Wilson County raster itself, if I preview that in our catalog, we notice that this is one big raster data set. So it's been a lot of overflight information that was tiled together to create one bigger raster. Another way to organize your information might be to pull the information into a raster catalog. So if we take a look at a raster catalog, we can take a look at all the individual entries of the catalog, and what happened here is it's actually storing each one as an individual object, and it's saving all of the overlap information. So in the Mosaic, what it did is it put together the information as one big raster. Here I'm saving each individual one and then showing them together as a raster. One of the improvements that they've made at ArcSDE 9 is the ability to show kind of an overlap, so between features and rasters. So what I can do is bring up another demo that I have that has the roads and with some raster information behind it. And let's say that I know that coming up very soon we're going to be changing one of the major roads, and I kind of want to know which rasters might need to be reworked. So what I could do is select a specific road and see what rasters that would affect or what rasters are involved. And if I select a different road, I can see that a different raster might be affected. What's happening, if we take a look back, is that ArcSDE is now saving not only the raster information, but also an envelope information about each raster catalog entry, so that it can show you which feature classes cross into that raster's boundary. Another use for raster catalogs might be to show the same information. So this raster is showing the entire world, but it's showing it at different time frames, and what this is representing is surface temperatures of the water of the world at different time frames to kind of show the El Nino effect. If I wanted to show a lot of people, maybe to say, hey, this is kind of the impact that this is having on us, I could bring that information into ArcMap, so I could bring the whole catalog in, and when I do that, I can show it over time in kind of a movie format to kind of show how this is impacting us, what is actually happening. When I did that, I brought in the raster catalog. I went to the display tab and I just clicked never show the wireframe and then redraw the entire raster every so many milliseconds. So in this case, 70 milliseconds. So some nice new functionality that's been added at 9. And what I wanted to do now is kind of just review with you the benefits of ArcSDE. So ArcSDE for vector information, many formats can be loaded in. Once the information's in, ArcSDE is going to process the information very quickly using indexes and spatial indexes. For raster, the benefits are many formats can be loaded. Once I look at the initial raster, pyramids are available so that it can quickly show me the way zoomed out, look at the information, and then as I zoom in farther and farther, it can just pull the tiles needed to represent a specific area. So all the time it's pulling very little information, even though it has lots of information stored. So let me send it back to Kasha for some more questions.
I've got some really cool questions. I've got a question from Ali, who's asking, do I need Arc Editor for version editing, or ArcView is enough? Ali, unfortunately, with ArcView, you can view the data that is in ArcSDE, but however, you cannot edit. So you will need either Arc Editor or ArcInfo to actually perform the edit. I also have a question from Adrienne, who's asking, where do you set permission groups or roles? Is it in a database, such as Oracle or SQL Server? You got it. That's absolutely where you set it. So you would go into SQL Server or Oracle, actually create database roles, associate folks within those roles, and then do what Jim showed you in the demonstration, meaning use the names of those roles to give permissions to feature classes in Arc Catalog. So Arc Catalog will take those roles and pass that SQL statement to the supporting database to actually give permissions to those objects. The reason that we recommend that you do that is because a feature class on the database level is actually composed of multiple tables. So doing it through Arc Catalog actually simplifies your task, because you are able to give permissions to multiple tables and and stored procedures by just clicking it, giving permissions in the client. I have one more question from Nabil. Does ArcSDE support MySQL? And the answer is no. We do not support MySQL. We support SQL Server, Oracle Informix, or DB2. And I'll take one more question from Adrienne again, and she's asking, why is service always 5151? Actually, I was laughing a little bit because 5151 is a port number that ESRI has actually appropriated. We actually bought this port number for ArcSDE. However, if you're going to have multiple services running in your system, you will have a port number associated with service. So your first service, the ESRI_SDE, is going to go through 5151. A second service, let's call it a Kasha service, is probably going to go through 5152, and so forth. So each service is going to have its own port number. Jim?
Thanks, Kasha. So I've got a question that came in about how do I connect external data to join layer attribute information. So in the example that I showed you where I actually joined those two tables together, what I did is I created a spatial view. And a spatial view works in a way that it's basically tying the information together in a view, but it's a view that's actually registered with ArcSDE. So when people look at it, it looks like a feature class to them. It has information in it. You can bring that back and look at it. What I like about the view is I can set that up in the background. I can make sure there's indexes on it. I can make sure it's efficient. You can also do joins and relates in ArcMap itself and join information together as well. So another question that came in from before that I kind of wanted to go over here was a question came in about loading information. So they've got lots of information to load in. How do they go about loading all this information? Is it going to be a manual process or a ton of work for them? And when you load information in, we could pull our information through our catalog. So I could go to our catalog and I can find maybe some information that's available to me and click on that information. I could right-click, export that to my geodatabase, and it comes up with kind of a wizard format for me. So a dialog where I can actually start inputting where the information needs to go to, and I can browse to everything, click in there, and get that information. Optionally, what I can do as well is at 9, they've got the ability to take a look at some of like the data management or conversion utilities. And let's say that I'm using something like let's see here, where did I put that at? Well, let's say if I'm just doing a raster information, and let's say I'm doing copy raster. So I could double click this and it would walk me through the information, or I could right click in here and go to help. And when I do that, it brings up information about copy raster, usage, command line information, but also scripting syntax. And scripting syntax will allow me, show me the parameter information that I need to put in there, and actually give me an example Python script. So I can take this script, take it, edit it, change it for my specific information, and use that to create kind of an automated process for loading my information. So let's continue on and talk about performance considerations when setting up ArcSDE. So when setting up ArcSDE, when setting up and using any data in ArcMap, scale factors are very important. So we could pull, in this case what they did is they pulled all the information that they wanted to look at in the map, even way zoomed out. It's a lot of information, maybe too much to really look at when I'm way zoomed out. Something important here might be to, maybe I want to turn off the major cities until I zoom back in. So in this case they use scale dependency to turn off those major cities. It not only makes a better looking map when I'm all the way zoomed out, but it makes it much more efficient, especially for that individual who's pulling up the map. So they're not waiting as long for it to initially draw, then they can zoom into a specific area and get the more detailed information that they were looking for. So when you're using ArcSDE, the scale factors not only affect that individual person who's using that individual map, but now because ArcSDE is pulling its information from a database and a shared server, those resources that are saved can be used to process other requests. So it can be used much more efficiently in the whole organization. So another performance consideration for ArcSDE is the connection type. So an application server connection is the traditional connection. We put in the information to talk to a specific machine that's running ArcSDE, the port number ArcSDE is running on, and then ArcSDE handles the request. So it takes the request from the client, it changes those into SQL statements, it does the filtering and passes the information back. The performance considerations for an application server connection is it's going to decrease the work that the client machine has to do, it's going to decrease the work over the network slightly, and it's going to increase the load on the server machine itself. So the server machine is going to get additional processes for the different connections that will take up memory, take up CPU cycles on that server. All clients have the ability to connect to the database directly and pull its information. Both types of connections, though, the application server connection and this new direct connection, are both require ArcSDE software and ArcSDE licensing. So it's going to have to be set up. ArcSDE is going to have to be installed. You're going to have a license for ArcSDE. But the difference between the two connections is where the workload is happening. So in a direct connection, the client is taking on the responsibility for transforming the SQL statements. Its processes will actually swell up and use more memory and more CPU on the client machine. It'll use a little bit more networking resources, but when it gets to the server machine will use actually less resources. So ArcSDE will do a lot more work on the client. And usually when I talk about these two connections, I get a question, and the question is, well, which one's the better connection type? And I have a great answer for that is, it depends. So if I've got a server, maybe that's got plenty of CPU, plenty of memory, I probably can go with the application server connection. It's easy to set up. People can connect over and start doing the work. But if I've got a machine maybe that's a few years old, its memory and all its CPU are being utilized already to support the database, the underlying database, well then maybe it makes more sense to work with direct connects, especially if I've got client machines that I've just went out and purchased. They've got the newest CPUs, they've got a lot of memory, maybe a gig or 2 gig of memory on the client machines, then maybe it makes more sense to have more direct connects going in and getting the information themselves. The nice thing about ArcSDE is you don't have to choose one over the other. I can have some of my clients be application server connections. I can have other clients be direct connections. I can even have a direct connect and an application server connection from the same machine. So ArcSDE will allow you to store your information or really direct the database to store the information a certain way or in certain locations. So rather than store all your spatial information in the database like a big closet, what you could do is you could separate maybe small data from large data, data that's used actively versus data that's rarely used. I could separate information maybe that only comes in once every year or every couple years. Maybe like my overflight information only comes to me every 2 years. I don't want to back that up every day. I can put that in a specific area and only back that up as the information changes. What's nice about this as well is you could use this DBTUNE, which is used in ArcSDE to control your storage, and what that will do for you is I can separate things out like my repository from my actual data so that I don't have a situation where fragmentation occurs. So maybe my information comes in before it's all written, other smaller information is put in between so that the database actually has to do more physical reads to pull that information out back to my clients. So now that we're storing our spatial information in the database performance itself is very important to us. So one of the big things that we want to do is to make sure that the database is tuned correctly. One of the big things that you want to make sure about is that the database is using the correct amount of memory for the machine. Sometimes you'll come to a place and they have very big machines with a lot of memory and only a small amount of that memory is actually allocated to the database. In this case, what you could do is you can change the database configurations to use a little bit more memory and increase the performance of the applications dramatically. And hopefully they'll carry you down the hallway as a hero, and you'll give celebrations in your name. And then you can start thinking about maybe disk contention and other tuning possibilities. So maybe I want to take information that is used at the same time and have multiple disks, especially disk controllers, reading that information so that it can be coming back to the database at the same time. Maybe I want to use a RAID system where it can separate out my information, and a lot of disk controllers can be used at the same time. I also might want to start thinking about, if I'm using an active versioning database where I'm doing a lot of edits, of separating that data out from my regular data, because that data is highly active. Maybe keep that data separated so that it doesn't get fragmented with other information. I also need to make sure that I take my information, maybe like when I did that demonstration where I was off doing my own version, and make sure that that information eventually gets reconciled and posted up to the changes where everyone can see it in the default version. And then compressing my data, so making sure that my data stays clean, that I go through and run the compress utility that's in ArcSDE, it's available in our catalog, to actually make sure that the database stays clean, that it doesn't have a lot of edits out there that are no longer referenced but yet are still left out there. So we make sure that we clean that up using the compress utility. And in a highly active database, we might want to do this nightly. If it's a database that's not so active, maybe do this once a week. So for this software demonstration, what I did is I created a pretty ugly map. So what I wanted to do is show you kind of some benefits of scale factors. So I created a complex map. The complex map shows some road information, but also the parcel information behind it. So a lot of detailed information from way zoomed out. You can see it takes a while for ArcMap to actually render that information. What I can do, though, is with a little scale dependency, is actually change that to make it a much more efficient map. So I took the simplified map, and from way zoomed out, I just show the roads. And what I did is basically went to parcels, went to properties. In the general tab, just said don't show this layer until if I'm zoomed out beyond 7,000. So as I zoom in, and I've created bookmarks for myself so I don't get lost, I zoom into a little bit tighter scale, I can start showing a little bit more detailed information. So I can start showing the streets, the street names, and the parcels behind it. And it still comes up very fast because it's just a small section of the map that I'm bringing back. And then I zoomed in a little bit closer, and as I zoomed in a little bit closer, I started bringing in information maybe of the parcel IDs. So the roads, the parcels, and the parcel IDs themselves. So that's some useful information for setting up scale dependencies. Some other things that are very useful and very important when I'm trying to performance tune, especially from the client's end, is maybe to take a look at some options that are available in ArcMap when I'm creating ArcMap. So if I go to Tools, Options, there's this new layer visibility. So make newly added layers visible by default. By turning that off, what I could do is basically make sure that if I come in the morning and bring in maybe 14 layers, that they won't all get rendered and then I go back and turn them all off so that I can work with the 3 or 4 that I need to work on immediately. I can turn this off and I can bring them in and just select the specific ones that I'm interested in bringing in. So that will save resources not only for the person who's bringing in all the information, but also for everybody else because all that information is not being rendered over and over again. One thing I did want to show you with that complex and simple map with the scale dependencies that I forgot to bring up is I actually traced some of the task manager information. So when I did that complex map, we see that the overall server was spiked very high while the whole map was being rendered, and then it came back down. When I rendered the simple map, way zoomed out, I just showed the roads. These little couple bumps were that part of it, and then I zoomed in, got more information like the name of the street and the parcels, and then I zoomed in even farther and got the parcel IDs. So you can see that not only helped the individual map user, but also left a lot of resources available for other requests in the organization. So in ArcMap, some other things that we could do is I can go to another map and maybe set some rendering. So I've got some very complex rendering when I'm zoomed in, but as I zoomed out, I actually changed it to some more generic, less detailed information. But also what you can do is, when you're zoomed in and doing some work, I can actually build map cache. So map cache will reduce the amount of times it goes back and forth to ArcSDE. It shows me that I'm currently locked into my map cache. I'm only using my map cache. As I zoom out or move over, it shows me that it turns red because I'm partially in my map cache. And if it turns gray on me, then it means I'm totally outside of my map cache. So it'll reduce some round trips between the client and the database, saving some work on that end. What I can do as well is go to selectable layers. So I can go to selections, set selectable layers, and I can make sure that only layers that I'm interested in selecting are turned on. So that'll save not only some work, back and forth returns to the database, but also help me to make sure that I can select the specific features that I'm interested in. So for performance considerations, we want to make sure that the database is tuned properly. We're using the right amount of memory, not too much memory so that the server is actually swapping to disk at all, but enough memory so that the application will run efficiently and fast. I want to use scale factors as much as possible in the organization so that the resources can be used for other requests. I want to test and configure connection information so that take my newer PCs, maybe use direct connects for them, try that versus application server connections, and see how the resources will help my overall organization. And I want to use DBTUNE storage parameters to make sure that it directs the database objects so that they get separated, so that I don't have my repository information with my regular information, that I separate small objects from large objects, that kind of thing. So let me send it back to Kasha for some more questions.
Thanks, Jim. I've got a question here from Derek, and Derek is asking, can I set privileges for a single feature class that is inside of a feature data set? And my answer is no. If you set a particular set of parameters or permissions for a feature class that's participating in a feature data set, that has to be uniform for the entire data set. So you can't have read and write permissions on one feature class and just viewing permissions on another feature class if they're both in the same feature data set. I have a question from Matthew, who's asking, how do you check out data to a personal geodatabase for offline work? That is disconnected editing. That's what you're referring to, Matthew. And the way you do it is a button in ArcMap. If you don't see it on your toolbars right now, then go to Customize and find the disconnected editing toolbar. It's just going to be 3 buttons where you can check out the database and then check it back in. And it's just a matter of a simple wizard. And it's going to actually create the personal geodatabase for you to check out that particular version. I have a question from Jason that is kind of piggybacking off of Matthew's question, and that is, what are some pros and cons of checking out data versus versioning? Jason, in reality, checking out data, so disconnected editing, is a way of using versioning, except that you're doing it implicitly. Because when you check out when you check out some data to a personal geodatabase for disconnected editing, what in reality is happening, you're creating a master version on your master database, and you're also creating a version of that data to be checked out. So when you're checking back in, those 2 versions will be compared, and that's how data is brought back in. So you are in fact using versioning. However, when you check out data, you are taking all of that processing off of the main server, so everything is done on your laptop or your computer at work. So you're basically offloading that those feature classes, or that server. James, would you like to take a question?
Yeah, thanks, Kasha. A question came in, do you have better performance with ArcIMS sites using ArcSDE data instead of shapefiles? That also kind of depends. If I have just like a couple small shapefiles on my ArcIMS server, and they're basically being all cached in memory, then if I have them local on the same machine, yeah, I might get better performance for those few shapefiles. If they're on a file server, I'm going to get better performance using ArcSDE. If it's something like especially if I get large areas to cover or if I've got a lot of information, I'm going to get a lot better performance from ArcSDE down the road, especially as those files or the area that they cover gets larger and larger. I've got another question from David, and his question is, can ArcSDE catalog hold Mr. SID format rasters? And yeah, we can hold Mr. SID format rasters, but it's important thing to realize with Mr. SID is it's a lossy type. So that means that some compression has already happened to the file. So you might want to, if you have the original TIFF files, it might be better to actually pull those and work with those rather than pull in the Mr. SID types that have already gone through some lossy compression. So let me continue on real quick and just wrap up here. So for more information, we have a couple of virtual campus training seminars. One's Understanding ArcSDE Table Relationships, and then the other one is the ArcSDE Spatial Index. So some focused topics, you can go in there at your own pace, follow along, pick up some information that way. Also what we have is the instructor-led training. So we have ArcSDE Administration for Oracle and ArcSDE Administration for SQL Server. Both classes are 5 days. They go into a lot of detail on a lot of the subjects that I've just kind of brushed on or talked about, and it's really meant for the people that are going to be doing the administration, maybe the database administrators who are also going to be the ArcSDE administrators, people like that. So we've also got the Managing a Version Geodatabase, which is a new 3-day class, which is for sites that are doing active editing inside of ArcSDE, a lot of versioning, and it goes into troubleshooting, looking into the specific states, a lot of detailed information about versioning. We've got Building Geodatabases, which talks more about the schema setup. I'm doing a water district and I want to model my water district, keep track of my information that way. This will help you organize that, maybe create relationships between the tables, information like that. We've also got a new product called ESRI Developer Network, edn.esri.com. This is a new service, and a lot of people in class would come up to me and ask me, is there a developer license that I could get? And with the Developer Network, you're signing up for a subscription service for about a year, and they'll give you a year subscription then for an individual use license for ArcSDE, ArcIMS, Server Engine, a lot of the server products, so that you can try them out, show people, maybe demo them. Also, it's useful if I've got the production licenses out there, but I want to have a development to play around, to try things out in, and do things like that. We've got some ESRI product documentation. So we've got ArcSDE index for specific commands, a lot of documentation for setup, information like that. We've also got the support.esri.com. So at support.esri.com, they've got information so I can type in a phrase there, query it, and pull back specific information like technical articles, white papers, things like that. Or I can get useful information. Maybe another user had the same question, and I type in my information. I get his question plus the answer or the response that he got back. So a lot of useful information there. So on behalf of ESRI, I'd like to thank you for attending.